Alright, this is the 2-4 podcast, and here we're talking about objects that, here we are talking about objects that are in motion, and we're talking about how those objects are, if they're moving in a constant speed in a straight line, their paths are said to be dynamic. They're said to be in a dynamic equilibrium instead of a static equilibrium. Let's change our pointer. Here we go. So, like we said, state of rest we've been talking about, and it's only one form of equilibrium. An object that's moving at constant speed in a straight line is also in a state of equilibrium. It's not changing its motion. And if there's no net force to change that motion, then it's said to be in equilibrium. One thing we want to make clear is if there's one force on an object, it cannot be in equilibrium. If there's no object force at all, or when you have two or more forces and they combine to zero, in other words, the net force on the object is zero, no force, or forces that cancel each other out, so to speak, then the object can be in equilibrium. So this gentleman's pushing this chair, or desk, across the floor, and he's gotten it so that the desk is sliding across at an unchanging speed, presumably in a straight line. In that case, the net force is zero. The force of friction on the desk and the force that he's applying, the force here and these forces here going in that direction, opposing his push, are equal. So let's talk about friction. Friction is the contact force between objects that slide against each other. And if he's pushing with the same force as the friction, then once again we have that sigma F equals 0, so there's no net force. An airplane flies horizontally at constant speed in a straight line direction. Its state of motion is unchanging. In other words, it is in equilibrium. Dynamic equilibrium, because it's actually moving. Two horizontal forces act on the plane. One is the thrust of the propeller that pulls it forward. The other is the force of air resistance, or air friction, that acts in the opposite direction. Which is greater? Well, the answer is neither. Because they cancel each other out, they have the same strength. And one we would call positive, the other we call negative. But the plane is in equilibrium, so the two forces combine to equal 0. So how are static and dynamic equilibrium different? Objects at rest are said to be in static equilibrium, whereas objects moving in a constant speed in a straight line path are said to be in dynamic equilibrium.